All right, this is lesson 3-1, day 2. So this is solving systems still, but with an algebraic method. And we actually have two algebraic methods. So method 1, substitution method, is going to be to replace some variable with the other thing, substituting that in. And then, so we've got two. We've got our substitution, and then we actually are going to talk about another one, elimination. And this was an Algebra 1 topic that you have seen before, so it should be reviewed, but it's been a while, so we'll kind of take it one step at a time. All the steps are on the left-hand side, and we're going to work through a couple of examples. So it just takes practice to get better at it. Remember that with substitution, you are replacing something else in that second equation. So get one variable alone and then substitute into the other. Missing, there we go, into the other equation. So think about which equation would be easiest to solve for. Be lazy. So there might already be one that actually has a variable by itself, which in the first one it does. Y equals this. So since y equals this, we're going to substitute instead of the y, so replace the y with this, because y equals this. So we can actually plug that in for the y value. So we keep the x, we keep the plus. The only thing that's changing is this y. Instead of it, we're going to plug the x plus 2 in. So no longer is there a y, we replaced it, substituted that in for it, and then equals 8. So now we can go ahead and solve since we have like variables. X plus x means I have two x's. And then we solve from there, two-step equation. So we wind up with 3 for x. Now that's only part of our answer because we actually have to find the y value too. So we're not done yet. And if you look at your steps over here, substitute it in, solve for the variable, which we did was x this time. Now we substitute that value into the original equation. So we're at step 4. So we're going to pick an equation up here. Let's just pick that top one. Doesn't matter which one you choose, but use an original one. And we have 3 plus 2. So we're just replacing, now that we know that x is 3, we're replugging it in up here. And now we can solve for y. And we write our final solution, because we have an x and we have a y, we write it as an ordered pair. So 3 is my x and 5 is my y. So this is my final answer for that system, 3, 5. All right, so if you want to try the next one on your own, remember you're going to get the y by itself or the x by itself, whichever one's easiest, and then you're going to substitute that value in to the other equation. So if you want to pause and try one on your own, that's great. If you want to just watch me do it, you can do that as well. So it looks like the easiest one for me, I could do either, but I could just subtract this 2x to get it over here, and now y is by itself. So I can replace y with negative 2x plus 6. So I'm going to go ahead and replace that y with that negative 2x plus 6. So no longer is there a y, I replaced it, and then I bring the rest of that equation down. Remember, you're plugging it into the second one. So now we can combine like terms, the x's, and we can solve. Now, a lot of times once we solve this, we think we're done, but we're not. We've only got part of our answer. Remember, it has to be written in this form, and we have only got one variable solved for at this point. So now we have to plug it back in, and it doesn't matter which one you plug it back into, but use one of the original equations up there. So we'll use the top one. 2 times 1/2 plus y equals 6. So half of 2 is 1. And then subtract the 1. So we get 5. And if y is 5 and x is 1/2, that ordered pair would be 1/2, 5. And that's our final answer. All right, next we're going to look at the second method, which is elimination. And this one's my favorite because you get to cross something out and it kind of seems like it's getting simplified right off the bat. So we want to stack the like terms. Well, they're already stacked. X is above the x, y above the y, and the constants above the constants. We're going to then create a pair of opposites. So meaning if this is a 3x, I would want a negative 3x. So it to be exactly opposite. Or if this is negative 5, I'd want this to be positive 5. So creating opposites. And it doesn't have to both be just one of the variables. So you can either multiply one of the equations or both of the equations. So I'm going to do, it's easiest if I were to try and make this a positive 5 so that it would cancel with this one. So in order to make this a positive 5, I'd need to multiply this whole equation times negative 5. So that negative times the negative would change it to a positive 5. So if we went ahead and did that, multiplied each term, I'd get negative 25x plus, because of that double negative, negative times the negative there, would change it to a positive. And then negative 5 times 19 would be negative 95. So now I'm going to actually just bring down that first equation. I didn't change anything on it. And now they're kind of stacked nicely. So I can kind of just ignore these two up here. I'm looking at this one's, it's still equivalent to this one. Now we can go ahead and cancel and eliminate because negative 5 plus 5 means 0. They cancel out, they eliminate. And now I add my x's, so it's negative 22x, and then over here add your constants, and then we can finish solving. So again, we have our x value, but we're not done yet because we need to substitute and actually find our y value. So there's always two answers kind of to these, your x and your y you're solving for. So plug it back into one of these equations up above here. It doesn't matter which one. Let's go ahead and just do that first one. So 5 times 4, or sorry, that second one, minus y equals 19. So this is 20. And you can already see that 20 minus 1 is going to give you 19, but we'll subtract 20 and then divide by negative 1. So y is 1 and 4 is x. So we have 4, 1 as our ordered pair, as our solution. So go ahead and try these next few. This one is already actually set up for you to eliminate the 3y and the negative 3y. So you can cross those off, add your x's, add your constants, solve, plug it back in. So really try that one on your own. So pause the video now. And then let's check our answer. So canceling those, we wind up with 6x equaling 30. So x is 5. And then when we plug it back in, doesn't matter which one, we would wind up with y as being 8. So plug it back into one of those equations, that x, and then write your ordered pair. All right, the hardest part I would say would be to come up with those that cancel. So a lot of times you might need to multiply both equations like this next one. So you're going to have to multiply this one times negative 3 and this one times positive 2, and that would create a pair that would be negative 6 and 6x. Remember that you have to multiply by every single term though. You can't just change one, and that should be a minus 12y. Or plus a negative, I guess works. And then that last one would be a positive 30. So multiply every single thing. Don't forget that part. 2 times, that would give me a 6y, and 2 times negative 3, negative 6. Now our x's cancel, and we can add our y's, and we wind up with 24. So that would give us y as negative 4. Plugging it back in to either original equation, and we'd wind up with x is 3. When we'd plug that back in, and there is our solution. Make sure you have both x and y. That's a big thing. Last thing we're going to talk about is when you have an identity or a contradiction. An identity means you have all real numbers, and then a contradiction means you have no solution. So we're going to have an example of each down here. So you can use either method, doesn't matter, unless it tells you specifically. So this one I'm going to use elimination, because if I multiply this one times negative 8 on every term, I get a negative 56. And that would end up canceling out. Oh, that'd be a positive 32. And my first equation, I'm going to just rewrite it so that it's right above it. Easy to add then. So notice that I get 0, 0 equals, and then over here 0. So when 0 equals 0, that's true, which means that we have an identity. Identity. Same thing equaling the same thing as identity. So that means all real numbers would work. Any number I could plug in for x and y, there would work and be correct. So next, on this one, we would multiply by 3. I'll just use, again, elimination. It's my fave. So negative 6x minus 3y equals 18. Rewriting the top equation just above it. And then I wind up with 0, 0 on this side. And then over here I wind up with 6. And that is not true. So that means that there is no solution for this one that would work when I have that contradiction. All right, and down here is just a summary of the different types that we've talked about. Graphing, we haven't really talked about a table, but graphing, substitution, and then elimination.